In this demonstration, I'll show you how to find the definite integral using the fundamental theorem of calculus. This is part 2 of the series. As discussed in part 1, to find the definite integral, you need to find the antiderivative of the function that's provided, which is denoted as this big F, and then evaluate the big F at your lower and your upper limit, a and b. Let's get started with question number 1. In question number 1, they ask us to find the area underneath the following function between -1 and 2. Essentially, that's what we're doing when we're finding the definite integral. We're finding the area underneath the curve. And the function that they have for us is 2 to the power of x plus x to the power of 2. Now above, I've included a table of useful antiderivatives. The one that we'll use for this term will be this one, but not to be confused. Now look at the antiderivative of e to the power of x. What's not shown here is the division of ln e. So essentially whatever your base is, and in our case it's e, you will ln e it. But since ln e is equal to 1, it's not shown. So do not be confused. The antiderivative of 2 to the power of x is equal to 2 to the power of x over ln 2. The antiderivative of x to the power of 2, that's simple. You increase this by 1, and then you take that number and divide it by your function. So x to the power of 3 over 3, and there it is. That is your antiderivative. Now what we have to do is evaluate this at both a and b. We'll start off with b. 2 to the power of 2 over ln 2 plus 2 to the power of 3 is equal to 8. And we can also replace this with a 4 over 3 minus, we're going to use -1, 2 to the power of -1 over ln 2 plus -1 to the power of 3 over 3. Now, just to be clear here, this would become simply -1, and so I'm just going to replace this with -1. And 2 to the power of -1 is the same thing as saying 1 over 2. So I'm just going to place that 2 underneath here. I'm going to evaluate this in our calculator. Bracket this first term, close that, minus a third. And if you do that correctly, you end up with 8.42. 8.42. Let's move on to question 2. In question number 2, they want us to find the area underneath the curve of sine x plus 1 between the intervals of 0 and pi over 2. Well, the integral of sine x, according to this table, is equal to negative cosine x. So that's the antiderivative, negative cosine x, and the antiderivative 1 becomes simply x. And now we're going to need to evaluate this both at your b and your a. Let's start off with our b. Negative cosine at pi over 2 plus pi over 2 minus negative cosine at 0 plus 0. So we know that cosine at pi over 2 will equal to 0, and you can use your calculator to confirm that. And cosine at 0 will equal to 1. So if we simplify this, we end up with pi over 2, and this simply becomes plus 1. Now think about it. You have a negative, it becomes a positive. And that's all she wrote. Let's move on to question 3. In this question, they want us to find the integral between 0 and 1 for x to the power of 5 minus x to the power of 3 over 2. X to the power of 5 becomes x to the power of 6 over 6. And this becomes minus 4x 3 over 2 plus 1, which is equal to 5 over 2. And then you take that 5 over 2 and you put it underneath. Now it's easy to get carried away here without simplifying, so make sure you always take your time to simplify carefully. And if you don't know how, use your calculator. So we have x to the power of 6 over 6. I'm just going to simplify this, make it look nice and neat. We end up with 8x to the power of 5 over 2 over 5. 4 divided by 5 over 2 is the same thing as saying 4 times 2 over 5, hence the 8 over 5. Now we need to evaluate this between 1 and 0. Now if we evaluate it at 0, all of it goes to 0, so all we really need to do is evaluate it at 1. So if I put a 1 here, I end up with 1 over 6, and if I put a 1 here, I end up with 8 over 5. 1 over 6 minus 8 over 5 gives us, well, let's do the math here. 6 times 8 is 48, 5 times 1 is 5, 6 times 5 is 30, and so we end up with negative 43 over 30. So there you have it. Those are 3 examples on how to find the area underneath a function for definite integrals. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.